Hey everyone, it's the Somewhat Tutor and welcome back to another video. This time we're going to be working through simultaneous equations using the substitution method, my preferred method. And I'll show you why it leads to a 100% success rate if you follow it correctly. So let's start with an example as usual. In the previous video we saw the equation 3x plus 2y equals 17 and 4x minus y equals to 30. So that's equation y, that's equation 1, and that's equation 2. And then we looked at the acronym DASS, difference, add, same, subtract. But this time we're going to look at the method of substitution. What that means is we're going to look at either equation 1 or 2 and isolate to get a single factor either in x or y. So we're going to make either one of them the equation of the subject. So as we've already got a single y in equation 2, what I'm going to do here is rearrange equation 2 to make y the subject. So we've got minus y is equal to 30 minus 4x, as we've just minus 4x from both sides. Therefore, timesing it all by minus 1 to get a positive y is equal to 4x minus 30. And now this is our new equation number 3. Y is equal to 4x minus 30. And what we're going to do now is substitute equation 3 back into the equation that we've not touched, which is equation 1. It's always the other equation. So if we made, for example, y or x the equation of x the subject of from equation 1, we must then substitute it back into the other equation, which is number 2. So in this case we're going to sub 3, the newly formed equation, into equation 1. So that's 3x plus 2 lots of the y, which is 4x minus 30 equals to 17. So let's expand that through. We've got 3x plus 4 multiplied by 2x, which is 8x, and then the 2 times minus 30, which is minus 60. That equals to 17. So again, we're going to clean this through. 3x plus 8x, common factors of x, that equals 8x minus 60 equals to 17. Let's isolate the x term by adding 60. So we're going to add 60 to both sides. That is 11x is equal to 77. And then dividing through by 11 is 77 divided by 11, which is x is equal to 7. Brilliant. Now what we can do is substitute this newly found x equals 7 into the equation we've just formed in number 3, as it's already isolated for y. So what we can do is substitute x is equal to 7 into equation 3. So that's y equals 4 multiplied by 7 minus 30, which is y equals minus 2, and that's exactly what we found in the previous video. So this is why this method always also works with these sorts of equations here, but also in the next example is dealing with powers. So let's just clean up the screen and we'll begin the next example. So this is going to be a little bit more tricky, so let's take this real slow. So we've got x squared plus y squared is equal to 29. We then got y minus x is equal to 3. So if you want to pause the video and have a go yourself, by all means please do. If not, we'll carry on. So this is going to be equation 1 and equation 2. So now let's rearrange either equation, but it might be simple to not touch the power terms, as we're going to be dealing with roots if we try to isolate either x or y. So always try and get the single power terms. So let's deal with equation 2. So we can either get x or y as a subject. As y is already positive on this side, we can then just rearrange the equation by adding x to both sides. So that's y is equal to 3 plus x, as we've just moved the x over to the other side. Now this is going to be our new equation 3. Again, remember, we must always substitute the new equation into the equation we've not touched, which is substitute equation 3 into equation 1, as we've not touched it. So we've got x squared plus y squared, so we've got 3 plus x all squared is equal to 29. As we've got a squared term, let's just do this on the side. We've got 3 plus x multiply 3 plus x, so that's itself. Expand that through, we've got 3 times 3, which is 9, 3 times x, which is a positive 3x, x times 3, which is another 3x, and x times x, which is x squared. So that equals 9 plus 6x plus x squared. Now we can bring that here. So we've got an x squared plus this 3 plus x squared, which we've already found out to be 9 plus 6x plus x squared equals 29. Now, can you see where we're leading to this? This is going to be a quadratic formula. We just need to get it in the form of ax squared plus bx plus c is equal to 0. So we need to clean this up by collecting the like for like terms and add it and getting the equation to equal to 0. But also remember to get it in the highest power first and decreasing in order. So we've got x squared plus the x squared, which is 2x squared, and then we've got 6x in the middle, and that's alone, so we've got 2x squared plus 6x plus 9 is equal to 29. So that's minus 29 to get that to equal to 0. So we've got 2x squared plus 6x minus 20 to the 29, which is going to be minus 20 equals to 0. As we've got a common factor of 2, we can divide this equation by 2. So we've got x squared plus 3x minus 10 is equal to 0. And now remember what we did in the first few videos. We have to find the coefficients of this equation a, b, and c. So we know that a, looking at this equation and the form, a is equal to 1, b is equal to positive 3, and c is equal to negative 10. So we need two numbers, then when you times them, equal to a plus a times c, but when you add them, equals to b. So a times c is 1 times negative 10, which is negative 10, and b, which is standalone 3. So two numbers that when you times them equal to minus 10, but when you add them equal to positive 3. So we've got 5 and 2. When you times them you get positive 10, but we need a negative 10, so we need a minus term. That could be minus 5 or a minus 2, but we need a positive 3 when you add them. So that must mean it's going to be a positive 5 and a negative 2. So you get minus 10 when you times them, but when you add them you get a positive 3. So what we can do is split this into two terms, which is going to be our positive 5x minus 2x. So as that still equals to 3, drop the two terms down, which is x squared, and then the minus 10 equals 0. We then split the first two parts, factorize what we can from here, so we've got a common factor of x, and then we get the x squared, we multiply by x. To get the 5x, we multiply by 5, and whatever is in this bracket must be the same as the other bracket. So we've got x plus 5, and on this side we've got minus 2x minus 10. So if we just compare the first terms of x, to get to minus 2x we must multiply by minus 2, and if we expand to the other side, minus 2 times positive 5 is minus 10, so that works out. We then again group the brackets, so we get the brackets that we've got in common, which is x plus 5, so these two brackets is the common bracket, and then we just group everything outside, which is x minus 2. So all we have to do now is get the roots. So we know from this one we've got x is equal to negative 5, and from this one we've got x is equal to positive 2. What we can do is then substitute these back into equation 3. So the equation that we've already found here to get the y term, so that's going to be really, really simple. So we've got y is equal to 3 minus 5, y is equal to minus 2. And then when x equals 2, we've got y is equal to 3 plus 2, y is equal to 5. So we've got the coordinates of when x equals minus 5, y is equal to minus 2, and when x is equal to 2, we've got a positive 5. So if you've enjoyed this video, please do like, comment and subscribe, and I'll catch you next time.